We're a company called Next Wave Automation. We manufacture smaller scale hobbyist CNCs. So I know first reason most of you guys are here is you want to know what a CNC is. So CNC stands for computer numerically controlled. For your woodworkers, just think of it as a computerized router. Everything you do on it works around a router. So the machine we're going to be using today is our CNC Shark HD4. It has a 2x2 cutting base with a 7-inch height. So the basic way a CNC moves, it's a 3-axis CNC. It moves in 3 different directions, X, Y, and Z. So X being left and right, Y being back and forth, and Z being up and down. So the way it works is through the computer you design a program that you save onto a flash drive that actually drives the machine. So everything actually runs through this little pendant here. And we'll go over a little more about that later. So CNCs can do pretty much anything you ask them to, from the top down. Now, then that means 2D, 3D, it can pretty much, if you can think of that router moving around a space, it can carve it out. Whatever you tell it to do with any bit, at any speed. So I'm going to pass around a few samples here. I guess I can start here, doesn't matter. But just small things it can do. I'm passing around a plaque. These are all customer made. Some of the ones I picked out that I feel are the best. Shows a few different things it can do. I'm also passing around a laser engraving sample. We have a laser accessory for this as well that acts like a wood burner. It'll just etch like this. So here's that. So anytime you use a CNC, whether it's ours or any other company, the first thing I like to do is have an idea of what I want to do before I cut something out. Because you don't want to go into the software blind, not know what piece you have, and try to cut something exactly to size like you set it up in the software. So for this demo, I'm just going to do a simple engrave. I want to start from the beginning, show you guys how to kind of set a piece in the machine, and from there go to the software from start to finish, put something in it, and engrave it out. So what we're going to do here is work with a piece here that's 7x7 with a 3/4 inch height. So the first thing the software is going to ask you is what's the size of your material, which I just told you. But it also wants to know a point of origin, because you can move, there's no specific place on this machine that you have to cut at, right? You can start at any point on this machine. So right now, obviously, we have this setting in the middle, but I could put it to the back right corner, anywhere you want. You just have to set a point of origin. And we were talking about the X, Y, Z coordinates. That's what's called 0, 0, 0. So right now, the machine, it has no idea where it is. So if I try to move it to a home position, it wouldn't know where to go. So we have to set that first. And that's the first thing I'm going to go over. So I'm going to try to do this, most of it, without opening the case here. But the point of origin we're going to set today is in the bottom left corner of the piece. Now you can do this on any corner or the center of the piece. It doesn't matter. You have 5 different options. So for some reason, I had 4 clamps on this instead of 2. I could put it in the center. Mark the center of the wood and just set my bit there. So it doesn't really matter. The standard is usually bottom left corner if any of you have been machinists before or anything like that. So what I'm going to do here is I'm going to move this bit over here, and I'm going to set my X and my Y first. Now I'm going to move the Z down to where I can get that bit as close to the corner as I can without actually hitting it. So for this, open this, you guys can still see it. So I'm going to try to put it here in the bottom left corner, as close as I can. To me, that is good enough. So for the X and the Y, I'm going to zero this out. Now for the Z, there's 2 different ways you can do the Z, the up and down movement. You can either manually do it, which is a little it's a little difficult because it's really hard to get it perfect on there because a lot of people will put a piece of paper under it and wait till the bit hits it or something like that. Luckily, we have what's called a touch plate. Everything about CNC is cheating. Yep. So what the touch plate is for is to set the Z-axis. Like I said, I don't want to have to sit there and jog it down in small increments and try to set it on top of the wood, because sometimes if you're going too fast and you miss and you get too cocky about it, you can easily run your piece in, break a bit, anything like that. So what the touch plate does, it establishes a magnetic current through your bit here and this touch plate. And what's going to happen is the bit's going to come down and touch this, and it's going to move up, and it knows that this is 3/8 thick. So it's going to know exactly where to put that bit on top of the wood. So I'm going to run through this here. And all it does is ask for a connection really quick. I've got one. Now it's going to allow me to move it down. Okay, so it touched it. It says my Z is found at 0.335, and I'm okay with that. So now, and remember, I already set my X and my Y. So now if I move this to 0, 0, which is my X0, Y0, it's going to come over here, and if I shoot it down to the Z1, there we go. So that's basically the first thing I always do before I machine something out, because the hard part is in the software, if I set all of this up and if I was even 1/8 of an inch off when I cut a piece of wood out for it, then I'd be in trouble. Everything would be different. So the first thing you always want to do is set the machine up. So now I'm going to go and start the software up, and we're going to explain a little more about job setup. Okay. Can everybody see here? Okay. So, like I said, Next Wave Automation, we developed the CNCs. The software you use with them is called VCarve, and it's through a company called Vectric. They're in the UK. This is very, very simple to use 2D CAD. Now these machines have the ability to carve out in 3D, but most things you do in here are going to be 2D and then convert them to 3D if possible. So just really quick, I want to show you, because I know obviously with these machines, everybody's afraid of the software, right? The machine looks fun, but I'm afraid to turn on my computer and actually do this. So they have great video tutorials here. They have forums, websites. We're always here to help you as well. We have a great support team. And hopefully by the end of this, I can show you, obviously I won't get too in depth here, but I do want to show you guys that it's very simple to do. Anybody can learn this. So first thing I'm going to do here is create a new file. Now, it asks you for your job setup. Well, we just kind of did most of this on the machine already, right? We just have to enter it in.
Yeah.
So you do have the option to do single-sided and double-sided machining. For this demo, we're going to do single-sided. We're just going to do a basic engraving. But double-sided machining basically allows you to take 2D CAD like this and create something in 3D. So machine half of it out, flip your board over, do it on the other side. So if I selected double-sided machining, it would walk us through all of that. Now, due to time constraints, I can't do anything double-sided today. But if you have questions about it after, let me know. So I know my piece, now I already did this, but I'm going to put some random parameters in here just because I want to show you how it tries to give me a visual representation. So right now it's set at 12 by 5, obviously that's not my piece in there. So you can see as I adjust this, that white rectangle there adjusts as well. So my width, my X direction is 7, and my Y direction is 7 as well. And my thickness is 3/4 of an inch. Now for an engraving, you don't always have to be perfect on this, but if you do have thin material, you may want to enter in the thickness as perfect as you can, because if it doesn't know what the thickness is exactly, and it'll warn you if it's going to go through your piece and into your bed, and you don't want that to happen. So always try to set the thickness as close as you can. I know sometimes something's 0.76 or something like that, but just get it close. And if you're engraving, it's not as big of a deal. So for us today, we're not going to worry about it. The Z0 position. So it's basically asking you for that up and down movement. Where are you going to zero that bit? So right now, we have it on the material surface. If I wanted to put it on the machine bed, I could do that and run the Z from there. So it would start on the machine bed, come up, and start working on the piece. Now, not too many cases, especially with these machines, you would actually do that. I don't think I've ever done it. So, like I said, rare cases, yes, that's why I'm explaining it, but most of the time you're going to keep it at the material surface here. So your XY position, that's what we talked about with one of the four corners or the center. Where do I want that bit to start? So obviously I have it at the bottom left corner right now, and that's where this little square is representing there. Now, obviously if I did the bottom right corner, I'd have an issue because I have a clamp sitting there, right? So that's why it allows you to move it into a bunch of different positions. Because sometimes, and like I said, sometimes you put 4 clamps on there. Well, how do I zero out my X and my Y if I already have this in here? You just mark the center and you can do it from there as well. So we're going to set the bottom left corner right now. Modeling resolution, and the appearance, these are both just for giving you a preview of what it's going to look like at the end. It's just going to change the color of the piece of wood in the preview. So set that to whatever you want. Sometimes I just do a solid color, it doesn't really matter. So I click OK, and it's going to open my left side here, my design side. Now, any of you that are familiar with CAD, this is, if you know, I know probably a lot of you have used AutoCAD, things like that. This is not that. This is not really complicated. It's very, very basic. So it gives you basic file operations here, so create a new file, set job dimensions, anything like that, save. But the main thing I want to focus on here is the creating vectors. So you have the ability to start from scratch and build something from the ground up in this software. So it gives you the basic tools to do that, you know, draw a line, draw a circle to this exact diameter, polylines, text, anything you can think of. So out of all of this, the most popular one probably being the text. The nice thing about CNCs is the personalization, right? And if you ever want to, you know, a lot of people get these for as hobbyists, but a lot of people want to make money on these machines. Well, how do you do that? How do I have an Ohio State flag? How do I sell this if every place I go to around here has one? Well, I can put your son's name on it, I can put your granddaughter's name on it. Anything you can think of, you can do on these. So the personalization is what really makes CNCs nice. I can see the dog agrees. So I want to go through just a couple basic text functions. Obviously, draw a circle, draw a line. It's pretty self-explanatory. Like I said, I don't have time to go through every little function, so if you have questions at the end about something certain, feel free to ask. So the text, all it is you click on it, it brings up a little box. You can type whatever you want in, so I'll just type Hartville in here. Now the font, what's really nice is they give you a lot of defaults. So you get your basic font, you know. But the nice thing is if you use Microsoft Word, or some people even develop their own fonts, you can add those in here as well. So you're not really limited to what they give you. You can add fonts in all the time. So I've actually had probably 10 different customers, you know, that would create their own fonts and bring them in. So you can do single line font, true type font, sorry, it doesn't really matter. So you can make it bold, italic, set the alignment, pretty much anything you can think of. And you can also wrap font, and it's in a different function, but you can wrap font around a curve too. So you see a lot of military flags where they'll have the circle and it'll say, you know, U.S. Army, all the way around, have someone's name on it. You have the ability to do that as well. So I'm going to click apply here, pop this text in. Now, I'm not just stuck with what I said. So I'm going to just put it in the center here. Obviously, I can move it around. So if I had something down here, I can move this, wrap it around. Doesn't really matter. I'm not limited to the size. You can adjust the size on anything in here. So, but what I want to talk about is this. What I just created here is called a vector. And what a vector is basically, I always try to say the lines that the machine's going to follow, right? This is what, all of these lines are what your bit's going to follow when you tell this machine to actually run. So any type of vector here, whether it's this text here, it's an image, anything you can think of, you have the ability to resize. If I wanted to, for some reason, take the V out of this, I could. If I wanted to jump back in here and add hardware, I could do that. It's pretty endless what you can do with these. So for this demo today, I'm actually going to not do any text, but I'm going to import an image. Now, a lot of times people will come to me and say, you know, well, I have all these ideas, I want to make this stuff, but I'm not an artist, right? I don't know how to do any of that. Well, I'm the same way. You can put a piece of paper in front of me and I can't draw a stick figure. So if I can't do it on paper, how am I going to do it on here? And that's where importing comes in. It's the most used thing ever on probably any CNC machine. So you have a lot of different options in import. You can do, if you have existing files, like I said, if you use AutoCAD, SolidWorks, anything like that, you can bring in any DXF file, any drawing into this. It comes into scale as you set it. It works completely fine. You can bring in images, PDFs, JPEGs you get off of Google, which is actually what we're going to do today. So, and you can also do 3D models. So I know a lot of people work with 3D models. I do a little bit. You can bring them in and it'll machine it as well. So you're not limited to all of your design work in VCarve, so don't feel like you get it, but you're like, I'm trained in AutoCAD, I don't want to learn something new. A, you'll learn, if you train in AutoCAD, you'll know how to do this without, at 5 minutes after you look at it. But B, you can take anything from that and bring it in here. But no matter what, you have to run everything and set your tool paths through this software. So what I'm going to do today is I'm just going to bring in a simple image and trace it. That's going to be our demo today. So this little button here says import bitmap. It's specifically for tracing. So I'm going to do Cleveland Cavaliers logo here. And if you're not a fan, I apologize. I try to keep it within the area here. So we're near Akron. Everybody's got to be a LeBron fan, right? So I'm going to bring this image in, but I can't really do anything with it because it's still just an image. So I don't have any vectors out of this yet. So how do I get there? This little bird here is the trace bitmap function. So that's going to take this image and trace it pretty much however I ask it to. Now that means I can do it in color. So if for some reason I wanted just to do the Cavaliers part in white, I would select white. And it would do the background as well. You can just delete that out. So the easiest way to do it though, and what I'm going to do today is do it in black and white. And basically what that does is it takes any image you bring in. Now, before I go any further, I just want to let you know, this came from Google. So it's not like you have to go and find some special DXF to bring in, anything like that. Just try to find a decent resolution photo from Google, or I've literally had pictures on a piece of paper that I've taken a picture of and sent it to my email and copied it on here and brought it in. So pretty endless what you can do when it comes to importing bitmaps. So when you click on black and white, it's going to turn whatever image you have into a grayscale image. And what's nice about that is you can do the color tracing, but most times when you import a logo, you want it to trace everything. So why go through selecting a bunch of colors for no reason? But when I look at this little area here. Well, if I go back to color, you know, I had some lines on this basketball here. Well, how do I get those back? You know, I made it completely blacked this out. That's what this number of colors threshold bar is for. And what that basically does is it makes it, you know, one way's dark, the max is darker, the minimum's lighter, and you can see as I slide it down here, it'll get a little lighter and it'll bring these lines back. And that's exactly what I want. So there's other parameters you can play with here, corner fits, noise filters, stuff like that. I don't really touch them that much. The threshold usually gets it to where I want, but if you bring in a photograph of, you know, something a little more detailed, maybe you'll play with those a little more, but not too much to worry about. So I want you to pay attention to this whole logo as I click preview here. Now you can see it just traced everything. So, but that's just a preview. So for some reason, now these lines look really good. It's always nice when you get it on the first try, but if it didn't look good, this time I could come up here, adjust this, and go back to preview, it'll retrace it again. So it's not like I trace this, I have to delete everything and go back. But I actually like what it did here. So I'm gonna click apply, and I'm gonna close it. So that basically just, all I have on this file right now is the Cavs logo, picture, and what I traced. So if I delete this picture, now I have vectors to work with. And that is basically the easiest way to get something from the internet in here. And you're not just limited to, you know, I brought this in and I'm stuck with it. For some reason I didn't want the eye in here. I could get rid of it. I could resize this, I could rotate it, I could do anything you can imagine with it without compromising its scale or anything like that. So I like how that looks, and we're about ready to talk about how to get this on the machine side, but I do want to talk just a little bit about the other functions here, and like I said, I'm not going to get too in depth, but you do have the ability for scaling, mirroring, any kind of small things you would do in Adobe Illustrator or a 2D CAD program. You have fillet options, trim. Now, in VCarve, what you receive with your machine is VCarve Desktop. So these are the functions that gives you. And like I said, we'll talk about more on the machine side, how you can carve 3D with these machines. If you want to 3D render, which basically means, I don't know where all those samples I pass around are, but this is definitely my creepiest sample someone's ever given me. I don't like bringing it, but it does make a good point here. If you want to take something like this, like do a face scan from a photo and raise it up here and do things like that, this is very, very intricate work. You will need upgraded software for something like this. So this is very possible to do in VCarve, but you will have probably 100 different tool paths trying to set this up. So they have upgraded software. Right now, it's called Aspire, and it's running, I think it's about $2,000. I'd say maybe less than 20% of our customers actually get that, because you don't need to have the ability to do this. This is actually something that people go to school for. Artists do 3D rendering. So it's not the same as just doing a prototype 3D model part and something. It's actually doing the artwork and raising, the hairline here and small things like that. So you do have the ability to do that, but it is upgraded software. So I just wanted to let you guys know that before I get too in depth with this. So I have my logo here, and like I said, it's a very basic demo, so this is what I'm going to stick with, but we do have the ability to do some more things. You're not just stuck with one thing. If I had all Cleveland teams and I wanted to maybe put the Cavs in one corner, the Browns in another, the Indians in another, you can do that. You're not limited to just one tracing function for the whole thing. And if I wanted to, I could put a profile around this. So if I thought this was, too large and I wanted to cut it down, I could bring another square in here. So I'm going to center this, and I could cut around these edges all the way through the machine. Now, one thing to know about that, if you plan on cutting through anything, put a spoil board under it, because there's no way you'll get it exactly 3/4 of an inch and not hit your machine bed. It's never going to happen. So always make sure, I always say if you get a CNC machine, the first project you should ever do is a spoil board. Just cover the whole thing. You have a 7-inch height on these machines, right? So if you take 3/4 of an inch or something like that away, I don't think you're going to have any issue in the future. So I'm going to delete that though, and we're just going to stick with an engraving today. So that's basically how the design side works. Does anybody have any questions about that? I know I didn't cover every little thing, but does anyone have any question about the design on here? Yes, sir.
And then, because you took it to a black and white, does that mean you're just working with 2 depths then?
Depths?
As far as which one is raised and which one is lower?
Actually, the image doesn't really work with depths. You set that on the machine side that I'm about to talk about.
We're talking keeping it like the regular colors. That had nothing to do with.
It had nothing to do with the depths of the wood. No, it more so has to do with. I would try to say this can trace stuff up to a point. So if I have something with a bunch of different colors, and first of all, it breaks it down into probably 15 different colors every time. So if I want to trace everything in this logo, which 9 times out of 10 you're going to want to do anyway. So why would I sit there and select a bunch of different colors when I could make it grayscale, make it 2 different colors, split it up, and it'll just trace everything. So that's all that means. And Setting the depths, that's all something we're about to cover here in a second. So anybody else really quick? Nope, all right. So when you're done with your design, you're gonna jump over to the machine side. So you're gonna set what's called a tool path. And all a tool path is basically, it's about 12 different ways to say, I'm gonna follow this line with this bit, at this speed, at this depth. So there's a lot of different ways you can do that. You can do profiling, where that's the most basic one, where you just follow basically what I just said, follow this line, this depth, everything like that. But it's not always that simple. Sometimes you want to do a pocket. So maybe I wanted to pocket out all of these Cavaliers letters. Well, obviously I'd have to draw a bunch of lines to make my bit follow it like that. So what a pocket tool path would do is say, okay, this E is enclosed, so I'm just going to do everything inside of it, right? So there's a bunch of different tool paths for that. They're all pretty self-explanatory though. You have drilling, so if I have a hole anywhere, it'll peck drill it for you. Quick engraving, it does. Inlays is a big one. Molding, prism, texturing, and fluting also for woodworkers, huge. And it also has 3D roughing and 3D finishing, and we'll talk about that a little bit towards the end here. But what I want to do today is I just want to engrave. So the best tool path for engraving is literally the V-carve engraving tool path. And what that does, it's always with a V-bit, and it'll set the depth for you if you ask it to. So it'll say, okay, I have a 7x7 piece of wood. It's basically going to take a V-bit, and between any two lines on here, it's going to, if you think a V-bit has a point on it, so if you want to see what they look like, there's one in there. But it's basically just going to come down like this between every two lines on here. So for this, I'm not going to do any type of depth because, like I said, this tool path sets it for you. But the tool is important, so I'm going to open up the tool menu. Now, this is important with any tool path, and it's probably the most important thing you'll set here when you're on your machine side of this software. Because V-carve, when it generates that G-code to actually run your machine, it will take this parameter, whatever bit you have, the parameters of it, and incorporate it into that code. So even if you have a 1/4 and 1/8 inch end mill, your cuts are going to look completely different if you select the wrong one. But what's nice is when you actually calculate a tool path, it's going to give you a preview of what it looks like. So if you did mess up, you're going to see it, and then you can adjust it from there. So I'm going to select the 60-degree V-bit here because I feel like V-bits are the best for engraving. A 60-degree is my favorite. That's usually preference. I think they do a little more intricate work than a 90. But I want to go over some of these parameters here because everything you set here affects what your machine does. The first thing is going to be the diameter. All of that's default, so you don't really have to mess with that. Now, they give you a bunch of default bits here, but if you buy a new one, like a new white side set, and there's 8 different bits in there, and 3 of them aren't in here. Well, what do? You can go over and create a new tool in here, and most bits you buy have some sort of parameters set on the packaging, right? So you go through there and just set these accordingly from whatever it says. You don't really have to do any guesswork on it. So the diameter of the bit, like I said, is usually pretty self-explanatory. That'll always be listed on the packaging of the bit. Now your pass depth, I'd say one of the 3 most important parameters on here that I'm going to go over. Your pass depth is how deep into the wood this is going to go at a time. So if I flip this here, and I'm going to jump out of this really quick and go to a profile tool path because it gives me more options. I'm going to go to an end mill here because they're a little easier to understand. An end mill is, think of a drill bit, but just with a flat bottom. So diameter of a 1/4 inch end mill is a 1/4 of an inch. Now your pass depth is always, like I said, how deep am I going into the material per pass. So the rule of thumb for wood, which I assume most of you will be using, is half the diameter of the bit. So if I have a 1/4 inch end mill, I could do a pass depth of 1/8 of an inch and so on and so forth. Now, this is fine for wood, but what if I'm doing aluminum? If I go in 1/8 of an inch at a time, my bit's going to snap in 2 seconds. So and that could be possible for harder woods too. So I've snapped a 1/4 inch end mill in that purple heart. I've done that before. I didn't go an 1/8 inch, I went probably 0.15 into it, which definitely when I first got my machine was one of the easiest mistakes. And I'm not a woodworker, so I hadn't really learned at the time I wasn't a woodworker, so I hadn't really learned the thickness of wood yet. So it happens to everybody. It's definitely something you play with, but these parameters usually work for 80% of wood now. And you can go on any forum, whether it's ours or Vectrix or anybody, and they have parameters set for, you know, if you're using oak, this is what these 3 or 4 people use and it works for them, and you can kind of go from there. We can always help you with that too. But, so the pass step, very important. Again, it's how deep it goes in the material at a time. So your step over, I would always leave that what the default of the bit is. That's basically, as you're machining, how far it goes over at a time. Not something I play with a lot. It matters more when you're doing light, like really intricate engraving, which we're not doing too crazy today. So your spindle speed, these machines, you can do 2 different things. You can use a standard router. So you see in there we have the Bosch 1617, right? You have a DeWalt, a Porta cable. We have clamps for all of these. But the other option we have is a water-cooled spindle, which is our own. And I will say the benefit of a spindle, they're 10 times quieter and you won't have to replace brushes and things like that. And they're just liquid cooled. Water is constantly running through them. They never have an issue. So, like I said, a lot of customers use routers just because when they buy a machine, they have one at home. So it doesn't matter. Quality-wise, they're probably about the same with your cuts. But the noise factor alone is definitely worth looking at the spindle for. But for a router, you adjust, you know, your RPMs of the router manually, right? There's usually a dial on the side of it. So your spindle speed, if you're using a router, doesn't matter. You can leave that and it's not going to affect anything this tool does. However, our spindle, we have an adapter that adjusting the spindle speed in here will adjust it actually when it's doing your cut. So something more to look at if you have a water-cooled spindle on your machine. So the other 2 really important ones here, feed rate and plunge rate. So feed rate being how fast in inches per minute my machine's moving in the X and the Y direction. So again, default 80 inches per minute is usually fine for wood. Now, the nice thing is we have a speed override on our machine, so if you have it set at 80 inches per minute and you think it's going a little too fast, maybe you're getting a little burn, some burn marks on your wood, you can cut it down to 40 really quick while the machine is running. Now, the plunge rate is the exact same thing, but it's in the Z direction. So these 2 are really important too because when you're, again, messing with thicker wood or you're doing aluminum or some sort of soft metal, you don't want to go in, you don't want your Z to go down at 20 inches per minute at 1/8 of an inch. So if I was doing aluminum right now, I'd set my feed rate at 30 and my plunge rate at 5. So instead of going in like this, it'll come down a lot slower. So you don't break your bit, you don't cause, you don't have a lot of heat issues or anything like that. So that's about every parameter you'll set in any of these tools, and that's with ball nose bits, that's with V-bits, end mills, doesn't really matter. So, but back to what we were talking about before with the engraving, like I said, I'm just going to go with a V-bit today. So I'm going to go back to my V-carve engraving tool path. I'm going to look at my V-bit, 60 degree, 1/4 inch shank, good, that's what I have in there. So I'm going to highlight everything, and I'm going to click calculate. This is probably V-carve's coolest feature. They actually give you the ability to preview what you're going to do before you do it. So I don't have to go through and waste 5 or 6 pieces of wood before my cut looks good. And this is very accurate. If you set, I tell this to everybody, if you set your bit exactly, you know, as you set all of your parameters exact, this preview will be accurate. So if for some reason, like right now I'm going to preview this, that's what our cut's going to look like, right? But if I go back in here, and I accidentally selected, let's say a 1/4 inch walnut bit, it's probably going to look terrible. But it may not, you never know. So I'm going to preview with that. That's not what I want. So it lets you know gives you every option to change whatever you messed up in here before you actually cut something out. So, and choosing the wrong bit is an easy thing to do because switching between a 60 and 90 degree V-bit, that matters. So I'm going to go back to my 60, calculate it, I'm going to fix this, and I'm going to preview it again. So that looks good, and you do have the ability to swap between different kinds of wood up here. That doesn't affect anything except for the color on here, so maybe you want to see what it looks like with light mahogany. A lot of them are accurate, a lot of them aren't. So it doesn't really matter. Again, it just kind of gives you, it's trying to give you the most accurate preview it can. So I always go with pine just because it probably looks the best on wood there. So now, this is just one toolpath we're doing today, but what if I have 3 or 4? Well, you can preview all of these toolpaths together or individually, it doesn't matter. But another cool thing that's cool is if I slow this speed down here and I preview it again, actually click on it and redo that. And I preview it, you see how it's actually showing me the process it's going to do? That's very accurate as well. So it knows exactly where it's going before I save this. So if for some reason you have a clamp that may be in the way and you're watching this and you're like, oh, my bit's going to hit a clamp, you have the ability to move that as well. So, like I said, this is about all we're going to do today, but I do want to touch really quick on the 3D finish toolpath because that's another popular thing here. So I'm going to open up one of my 3D finish files, and you can see a bunch of them up there. It's the eagle, the grapes, the ones that look like they have a dome almost. So those are files, 3D finish files that Vectric gives you for free, and they have a catalog online where you can go purchase some. And when you do buy one, and you'll spend anywhere from $2 to $30 on them probably, you have them for life, and you're not limited to the size they give you. So this eagle here, if you go to purchase this online, it'll give you 3 different options. You'll have the eagle in a dome, which is what it is now, or you'll be able to, kind of have it recessed and raised out of the wood, which is what most people like. And the third one, I don't really understand what it is, so I'm not even going to go into it. But so these 3D finish files, if you look over here, there's a tab here called clip art. Now, you can see there's different library folders. You'll have to add these in yourself. Just go to add folder and figure out where your models are, and that's all you do. But they pop up. Now, I don't have any here because I just got this computer, but they pop up like this file right here would look just like this, and it would say eagle. And all you would do is literally click it, drag it out here, and it scales it to whatever job site you have. So these files are really nice because they're easy. Hey, you don't really have to do any design work with them except for scaling it. And definitely, quality-wise, they're the best files you'll find. So there's 2 different ways you can do this. You can either, if it's a smaller piece, you can just do a 3D finish run, which is basically just taking a ball nose bit and doing this right off the bat. Which I think so I could just do that right off the bat, one run, doesn't matter. Now the problem with this is when you get into larger files, now this I have on a 6x6 or something like that. If I was doing a 10x10 and I did it like this, unless you have a ball nose bit with an incredible taper on it, eventually you'll start getting lines on it. So the way to avoid that is to do a roughing toolpath. So that's basically just taking a 1/4 inch end mill, an 1/8 inch end mill, whatever you have, and knocking out all of the space you don't need, and then taking the ball nose, going back and cleaning it up. So a 3D roughing toolpath, if I really just select a bit and calculate it, is all you do. What that's going to do, it's going to, like I said, it's just going to take a 1/4 inch ball nose and do that, and then it's going to take my 3D finish file, and I'm going to do it at a ratchet. 3D finish file is going to come back, and it's going to go through and clean it up. So, like I said, I know that was quick, but that's how quick it is to set these up. It takes 2 seconds to drag a file in here, set of roughing, set of finishing, and you're good to go. So it is a bit change, so remember that, but not really a tough one. So I just wanted to let you guys know. you do have the ability, and this isn't just with vector files, this is with any STL file you can find online. So again, if I was using AutoCAD or something like that, you can bring those files in and do the exact same thing. So, okay, I'm going to close this. We're going to go back to our other file. So the Cavaliers logo, that's set. I set my toolpath. Okay, I'm ready to save it. So before you save it, you do have the option to look at the summary of the time here. It's never going to be accurate the first time. Vectric uses 100 plus different companies. So obviously they're not going to know the time on our machine as opposed to a different company. So that's why they put that scale factor in here. So you'll adjust that accordingly after a few runs if you actually do care about the time it's going to take to machine things out. So I'm going to save this toolpath now. Really, the only important thing to remember here is the post processor. You have to select this one, the CNC Shark USB ARCS post processor. Every company has their own post processor. If you do not select that one, your machine could take off, go straight into the bed. I don't know. If someone's programming is different than ours, it will not work. So make sure, and this is all in the manual and the videos we have and everything, but I just like to reiterate that because this is definitely a beginner mistake. A lot of people do this and wonder why their machine's not working right. So I'll save this toolpath. I actually already did that to a flash drive over there, so I'm going to act like I saved it, but I'm not going to. So now we're ready to go to the machine. And again, the nice thing is, I'm in my office or whatever, I can leave my computer here. I don't have to have my computer collecting dust the whole time. So that's where these touch screens come in. So like we talked about in the beginning, I set up my piece, I did it in the bottom left corner, and I zeroed it out already. So you guys know how that works. So when you're ready to actually machine something out, and I'll see if I can get lucky here and actually get this on my TV up there. But I'm gonna, all right, and I can barely see this, so. Yes, no, does it look terrible? Okay. Okay, I'm gonna try not to move. So you see this USB button in the bottom right, can everyone see that? When you click on that, it's gonna bring up everything that's in that on that flash drive. So it's only going to recognize tab files, which is what the G code is that runs the machine. So when I save a file on there, that's called a tab file. Very important to know, especially because not all of them are tab files. So if you do save it with the wrong post processor, you won't be able to select it in here 9 times out of 10. But I don't think we're the only company that uses that. I think there's actually multiple. So my folder in here is called branded. I'm going to click on that. These are my 2 files. So the Cavs logo is called Woodcarving. So what that's going to open up is it's going to open up the G code, but it's going to open up the G code header first. So this is a really good way to double check what you're doing again before you run. So obviously I see my X, Y, and Z at 3/4 of an inch. My Z origin is the material surface, we know that, and my XY origin is the bottom left corner. So that looks good to me. Oh, I'm sorry. Yeah, other way. I can't see this at all, so, okay. There we go. All right, I will attempt not to move. There's only like 2 more steps, I promise. Okay. So you click next here, and if you do, if you're one of the guys that actually writes G code, more power to you. I do not know how to do that, but if you do scroll down and want to adjust this, you can. So you can see all the lines of code here. But luckily with our machines, you do not have to do that. It does it for you. So you click next, get a little message here that we'll talk about that later, it doesn't matter. So this is your run screen. It's your basic start, stop, pause, resume. So the speed override here is what I was talking about. While the machine's running, right now it's at 100%. So if my feed rate's 80 and I think that's too fast, I shoot it down to 50, it's going to be running at 40 inches per minute and so on and so forth. So this is all pretty self-explanatory. It's going to show you the time, how many lines are transmitted and how many lines have been sent, and your file size. Now, the important one, and I'm going to pull this away because, like I said, it's all pretty self-explanatory, but the important one is the E-stop, the red stop button. That is your best safety precaution. If for some reason you're machining, and like if I'm running this right now, and I start hitting a clamp or I'm in my machine bed, that's the button, that's the kill switch. Hit that. It will not forget your origin. but it will completely stop and you'll have to start over. If you're doing something and you just, now it's cutting out fine and you're just a little worried, maybe I might hit a clamp, I want to go look at my VCAR file real quick. Just pause it. It'll shut the router off and it'll just sit there, and if you resume it, it'll pause for a second to start the router up and it'll go again. So in an emergency, hit the E-stop. If it's just something you want to double check, hit the pause button. So the cool thing about using a router on these machines is the automatic turn on. So right now that router is actually plugged into this controller up here. And the router is actually on right now, but you see obviously it's not moving. Reason for that being, the controller won't kick the router on until the file is started on here. So it'll shut the router off if you stop it, if you pause it, and when the file's done. So if everything looks right, it's always good to triple check your stuff. I think everything's fine, so we're just going to go ahead and run it. So I'm going to click start here. Router turns on, it's going to start working on my feed. So this file, I did this demo yesterday. This file runs about 5 minutes. So what I'm going to do is I'm going to put my pictures back up there, some customer pictures, and let them cycle. Feel free if you want to come up here and watch it a little better. I don't know how it's showing pretty well in there, but if you want to look at samples, and then when this is done, in the next few minutes, we'll do a little Q&A, okay?
No, you're fine.
still? Good? Good deal. So that just got done. I don't know. I'm gonna pull it out of the machine here real quick and pass it around. One thing before I do the Q&A, I was just talking to someone about, and it is something I should mention. Like I said, obviously I'm doing a demo here. I'm doing a Cleveland Cavaliers logo. I was talking to you about how you can do logos of any team or anything like that. And most of you know this, but I'm going to say it anyway. Be very wary of trademarking. Because you think you can get away with it, you cannot, they will find you. I don't care if you sell 5 of these on Facebook. People get nailed with that all the time. I don't want to be the person that told you you can sell all of this and not, you know, pay the man, right? So you always have to work out some kind of deal with the schools or the NCAA or the NFL or anything like that. I don't do it, so I don't know really how it works, but I do want you guys to be aware of that because I have seen people get in a lot of trouble for that. So this turned out pretty good. You guys feel free, anybody wants to see it, pass it around. But I do want to do a quick Q&A here. We got about 10-15 minutes or so. So does anybody have any specific questions or?
How long would something like this?
Okay, he asked how long would something like this take. This is very, very intricate. So I would say a customer ran this for us, so I don't know the exact time, but this was definitely done with probably 3 or 4 different bits. And like you can see the incredible detail. I passed it around. This was probably over 10 hours, I would say. It could be more than that. Just because of the getting the bit in all these little areas and things like that, this was probably one of those, he hit the button, went to bed, and saw what it looked like in the morning kind of things. So, definitely, files like this do take a long time, but again, the nice thing as opposed to hand carving or something like that is if you're confident in what you're doing, you hit the button and you don't have to stand there and watch it the whole time. Like this file, I could have went and got some food, came back, and it's good to go.